So, hi everyone. So, today I'm going to discuss the lead code problem 1465, which is the daily lead code problem of July day 2, which is maximum area of a piece of cake after horizontal and vertical cuts. It's a medium problem on the lead code, and in this, I'll be basically discussing the code of the problem rather than going into much more details. So, as given in the question, we are given a rectangular cake of size h into w, and we are given two arrays of integers that are horizontal cuts and vertical cuts. So, the horizontal cuts contain elements which are basically these are those distances which are from the top to the which are from the top of the rectangular cake to the ith cut. Okay, suppose the distance is the element in the horizontal cut is 2. So the 2 implies that the distance from top to bottom is 2. Okay, so talking about the vertical cuts which are in this direction. So the vertical cuts, that is the element in the vertical cuts, is the distance from the left of the rectangular cake to the jth vertical cut. Suppose there is an element 3 in the vertical cuts. It implies that the distance of mm, distance of the vertical cut from 0th to 3 is from 0 to third element is 3 in the cake. So we are required to return the maximum area of a piece of cake after we cut each horizontal and vertical positions provided in the arrays horizontal and vertical cuts. And also we are given that since the answer can be large, we are required to return the modulo of 10 to the power 9 plus 7. So first of all, if we are given that the question says that the answer is large and we are required to return the modulo, simply just declare a variable mod and do this homework at once. And I guess this is the most easiest homework which we can do at the very starting of the question. So first of all, since we cannot write this horizontal cuts and vertical cuts again and again, although we are required to write, but we can simply just store their sizes in some variable like s1 horizontal cuts dot size, and in s2, which is vertical cuts dot size. So we have stored the sizes of both the arrays. So let's just discuss the first example before we proceed to the question. So as we are given in the question, we are required. It's given that we can cut the cake either horizontally or vertically, but it's quite possible that there is no position like the cake is not cut at all. So it implies that the horizontal and the vertical cuts array can be zero at any given point of time. So in order to handle that case, so the maximum of the area which we can have, like at an instant, if both the horizontal and vertical cuts of the area are vertical and horizontal cuts area are empty. So the maximum area of the cake is height into h into w, which is the because there is no cut at all. So the first edge case which we have figured out is that both the arrays are empty. So the maximum area is equal to height into width. Okay, so second edge case, it's really possible that the cut is applied at all of the distances of h and w. Suppose the maximum distance is 5 and the maximum width is 40. So the cut is applied at 1, 2, 3, 4, and in the width direction, and in the height direction the cuts are applied at 1, 2, 3, 4, and 5. So if at all it happens that both of the arrays have maximum number of elements, that is 1 2 3 4 5 and 1 2 3 4. So so the maximum area of the cake at that point would be 0. So the second edge case, so the second uh, edge case is when cuts are applied at all possible distances. So in that case, the maximum area is equal to 0. So this is the case when both of these are, when both the horizontal and vertical cuts have maximum number of required elements. Okay. So we can see that we are, so the maximum distance, there are two possible maximum distance that we are required to push in our horizontal as well as vertical cut area. First of all, we are required to push 0 horizontal cuts, no, push back 0, and since the horizontal cuts will go maximum till the maximum height of the cake. So this is the maximum height of the cake. The cake, and now in the vertical cuts, push vertical push and W. This is the maximum width of the cake. So now what we are actually we are required to figure the maximum area of the cake after applying all the possible cuts. So as we can see, there are multiple divisions that have occurred while we cut the cake, as we are given in the, as we apply the cuts according to the horizontal cuts vector and vertical cuts vector. So we can see that the maximum area exists at that point where the difference between the adjacent elements is maximum. So the difference between the adjacent elements can be figured out by sorting both of these arrays. So the next step is to figure out the maximum difference. Maximum difference over here means that is the maximum difference in height and max difference in widths. So that's why we are sorting the arrays. Cuts. Okay. So we have successfully sorted both of our arrays. So now we are required to tell the maximum width and maximum height. So maximum width and maximum height. So initially both of these elements are 0. Why so? Because our because the width and height have the constraint that they are always positive, as given over here. like their minimum as given in our constraints that the elements in both of the arrays are are greater than or equal to 1 and less than height and width respectively. But in this case we are pushing back both of these elements in their respective arrays due to the reason because we are having the second edge case, that is when cuts are, oh sorry, the first edge case, that is when both of the arrays are empty. Let me write the word first. So, and moreover, so it's already given in the question that the answer can be large. So, if the answer can be large, it can be greater than 10 raised to power 9, which is the maximum value where integers exist in our memory. So, we are required to take long int. Now we are required to traverse both of these arrays and check for the same. And like we are required to compute difference at each and every step, so I'll declare difference over here. Mhm. Horizontal cuts of I minus horizontal cuts of I minus 1. And at every instance, we are required to check the maximum height is equal to maximum of difference comma maximum of h. Okay, so same is the case for the next one as well. For the vertical cuts, just wait a minute, let me just check for the constraints. Hmm, okay, we are going to vertical. Okay. So here we are required to compute the width and also here width. And then we are required to return our answer, that is max of x into max of x percentage. I guess this is all of the code which we are required to do. Let's just run this code once. I was also thinking that we are required to compute the width and we are required to compute the h. We will run that code. Just wait a minute. Okay, one more variable which we are required to just wait. Let me. Okay. So one more variable which we are required to maintain is maximum of area. So just compute max of area over here, which is our maximum height into maximum width. Simply do the mod of both of these values and then just return. I guess it might be erroneous because of this one. No. Mm, this one. Okay, so I have basically made a few changes over here. Let's just see all of those changes. Okay, so my code ran successfully, and now we'll try to submit the code. and hence the code runs successfully.